Okay, and number 11, we are being asked to find the derivative of this rational function. So I can see my input is being sent to a variable base that has a constant exponent, but that variable base is located in the denominator of the fraction. So I cannot use power rule as this is written. Later, we'll learn something called quotient rule, which I can use if I want. A quotient is referring to a fraction, a numerator and denominator. But right now, I have some algebra I can do to rewrite this function to make it fit the power rule. So that's what I'm going to do. I'm just going to relocate this base to the numerator. It's a trinomial base to the third power. When I relocate it, move it up there with that 1, it'll be a trinomial base to the -3 power. And that's okay, that fits power rule. So that would look like this. I can write that 1 up there if I want, it's understood, but I'd have my trinomial base that stays exactly the same. I just change the sign of the exponent. Now I'm set up for power rule. Now my input is being sent to a variable base with a constant exponent. It's all in the numerator. You know, technically all of that is over a 1, right? So it's all in the numerator, and we can do our power rule. So let's go ahead. Our power rule says we drop the exponent down to the front. Okay, and now that I'm starting the power rule, I'm going to use F prime notation. I'm finding a derivative using the power rule. I'm doing calculus, so I need to use F prime notation to denote that. So I multiply my exponent times the coefficient. There was an understood 1 there. So that's -3. I rewrite my trinomial base exactly like I see it. I decrease that exponent by 1. So it's going to drop to -4. And then my chain rule comes into play. My chain rule says I tack on the derivative of the base. Since a power function sends the input to the variable base, my chain rule says you tack on the derivative of that variable base. And it's not just a plain old x, it's a trinomial. So I can't skip that step. The chain rule is really important in this problem. So let's go ahead and find that. Well, this trinomial just uses power rule in and of itself. At this point, you might just be able to see that the derivative of x squared is 2x, and the derivative of a plain x is 1, and the derivative of a constant 4 would be 0. You might be able to just see that in your head and go straight to the derivative of the base, but if you don't, just do the power rule. That's okay. And this is an accelerated course. You might not have time to absorb that, but you know the power rule. I drop my exponent down to the front. So that would give me my 2. I rewrite the base. I decrease the exponent by 1. And I tack on the derivative of the base. And then moving to the next term, there's an understood 1 exponent there. So I drop the exponent to the front. That would be a 1. I rewrite the base. I decrease the exponent by 1, so drop down to 0, and I tack on the derivative of the base. And we can just say the derivative of a constant is 0 because derivatives are rates of change and constants don't change. So we can just say that's a 0. But if you really wanted to do the power rule, you'd have to write in the x to the 0 variable that's understood to be there. And then when you do your power rule, you'll get 4 times 0, which would just be 0. So it doesn't matter what comes next. If you multiply anything by 0, the whole thing's going to be 0. But you can just say it's a constant. The rate of change is 0. But either way, you're going to end up with the derivative of the base being just a 2x. Ooh, we do not want to write that understood 1 there. Looks like a prime. But we know the derivative of a plain old x is 1, so we don't have to write that. And then on this last term here, we don't need to write that understood 1. The derivative of x was just a plain old 1. Anything to the 0 power is just 1. So that whole thing is 1 times 1 times 1 is just a 1. There. Okay. So that's the derivative of our base. So let's write that down. Okay, that would give us the -3, rewrite the base, decreased exponent times the derivative of the base was just a 2x plus 1. And you can stop here if you want. We like to keep this in factored form because later we'll set this equal to 0. So I'm fine with that. But my math lab will want you to take this derivative and rewrite it in the same format as the original function. The original function did not have a negative exponent. My derivative does, so I need to rewrite this derivative with only positive exponents. And that's going to be an important algebra step if I did need to set this equal to 0. I would need to have only positive exponents to do that. So let's practice that algebra step. Okay, that would mean my -3 here, that would stay in the numerator, it's fine. And this derivative of the base, that would stay in the numerator. But this trinomial with a negative exponent would need to be relocated. So the only place it has to go is down. I'd put that in the denominator, and then I write it with a +4 exponent. And now if I was asked to set this equal to 0, we know from when we did sign charts, or we know from algebra, that the only way a fraction can be 0 is if the numerator is equal to 0, but the denominator is not. We don't want a 0-0 situation, right? That's our case 2 where we have to do some more simplifying. But we could just set that numerator equal to 0, and then that's just, an algebra equation solve for x. You can distribute the -3 if you want. Divide off the -3 if you want. Do zero product principle if you want. There's lots of ways to solve that. But I could only do that. I could only solve the derivative equal to 0 if I relocated that negative exponent. So that base with the negative exponent. But anywho, okay, so this, we weren't asked to set it equal to 0 there. We were just asked to find the derivative. So this is what I would type into MyMathLab. Okay. Now, if any of that algebra is tripping you up, y'all, exponent rules, this idea of relocating a base and changing the sign of the exponent, if that's tripping you up, reach out to our instructional associates. There are like 8 instructional associates designated to help with algebra. I can help. Your classmates can help. Our embedded tutor can help. Get help. We're here to help. I know that algebra can be tricky. Okay. Keep on keeping on, y'all.